Yeah, good morning to one and all. Once again, I welcome you all for the structure analysis course, this video lecture sessions, and I am going to resume the previous topic. And I was talking in the previous class about the one numerical which is using the three moment equation can be analyzed, that is continuous beam. So analyze the continuous beam by the three moment equation and draw the shear force and bending moment diagram. So the simply supported bending moment diagram on AB and AC, since supports A and C are the simply supports and MA equal to MC equals to 0, and where the bending moment diagram ABC 90 kN meter and 45 kN meter, applying the three moment equation to span AB and BC, that is delta 1 equals delta 1 and delta 2 delta 3 are going to be 0, since those are support conditions. The equation can be applied here. MA 3 the span by I actually, so MA 3 by I plus 2 MB LAB by I AB plus of course LBA by IBA plus for the first one is MA into LAB by IAB plus 2 MB into LAB by IAB plus LBC by IBC plus MC into LBC by IBC equals to 6A1 x bar 1 by I actually. So the span into I, that is we are applying for the AB span. So that is why in the first portion that is put it as a LAB and IAB, whereas in second portion of that minus 6 into something, that is LBC into IBC actually. So if you interpret the all values, if you again look at the equation, that is MA into 3 by I plus 2 MB into 3 by I plus 3 by I plus MC into 3 by I equals to minus 6 into 1 by 2 into 90 into 3 into 1.5 by 3I minus 6 into 2 by 3rd into 45 into 3 into 1.5 divided by 3I, that is MB equals to minus 56.25 kilonewton meter. And analyze the continuous beam, the same thing, of course it is repeating, the values MB can be calculated, and the reactions at A, B and C are given as 41.25 kilonewtons and VA equals to 120 into 1.5 minus 56.25 by 3, and VC equals to 40 into 3 into 1.5 minus 56.25 by 3 equals to 41.25 kilonewtons. VB equals to 120 plus 40 into 3 minus 41.25 minus 41.25 equals to 127.5 kilonewtons. The bending moment and shear force diagram are shown in below, and those are in respectively. So the combined diagram of the bending diagram can be seen here, but the shear force diagram can be drawn with the help of the given load on the beams as well as support reactions actually. So if we look at the starting point of A support, that is 41.25, that is positive, and it will be repeated up to the next loading point, that is 41.25. 41.25 minus if you remove the load, then you will be getting 78, that is 120 actually kilonewtons. So if you remove that, and you will be getting 78.75, and it will be repeated up to the support condition at the center is B, and again due to the support reaction at the BRB, that again it is going into the from minus to positive, that is 78.75, and due to the UDL condition is being applied in the span of BC, the diagram will be linear, and that will be goes and at the end up at C, that is support condition, that is 41.25, but in between the bending moment will be 0, the wherever the bending moment sign is changing from plus to minus, that is called point of contact flexure actually. So that is all about the shear force and bend moment diagrams. So you can here see, of course, wherever the shear force is 0, the bend moment will be maximum, that condition also will be there. And this triangle shape one in the bend moment diagram, if you see this bend moment diagram shape is actually because of fixed end movements actually, so that is only will be having at the center. And whereas this one 90 triangle and 45 is due to, you have to assume the whole span into two simply supported, that is one simply supported with center point, another one will be 45. Then analyze the beam as shown in figure below by the three moment equation. Draw the shear force and bend moment diagram. The effect of the fixed support is reproduced by adding an imaginary span. That means whenever fixed support is there, you have to convert into one imaginary span actually, that is A naught A as shown in figure. The three moment inertia, the moment of inertia I naught of the imaginary span is infinity, so that it will never deform, and the compatibility condition at the end A, that slope should be 0, is satisfied. So that is the way you have to see and convert the span of the A, and the same load 120 kN is being given at the B portion, AB portion, and in the BC portion 40 kN per meter is being given. Then the whole span of the AB is 3 meters, and whole span of the BC also is going to be 3 meters. Then you will not have any diagram over here, since it is a imaginary span, does not have any load actually. Then the diagram will be like this when you see the simply supported movement diagram actually. But when you see the shear force diagram, again with the help of the support reactions, that is 60 kilonewtons will be there at the A, and and another 60 kilonewtons will be continued up to wherever the load is there, that is 60, and wherever the B is there, and again it will go to minus level, and it will be repeated, and it will go up to the at the top into the positive manner, since it is again a support condition at B, that is RB will be there, reaction at B, and that is 75, and it will be closing with the minus again at the 45 at the support condition actually. So then the whole diagram, now combined diagram can be seen here by having the because it's fixed support, the movement will not be 0 there, that is why that box is coming, and this is a simply supported one, that is why it is closing with 0. That is all about fixed movements actually. But if you see the another diagrams, combined diagrams, that is due to simply supported diagrams actually. So that is all about that. Then applying the three moment equation to the span A naught A and AB, so that is whatever we have done above. We are going to get one equation, that is 2MA plus MB equals to minus 135. That is we got from MA naught into L naught by infinity, otherwise span nothing but that is span also will be 0 actually. So that is going to cancel actually. So plus 2MA L naught by I naught plus 3 by I plus MB into 3 by I equals to 6 into 1 half into 90, because it's a triangle actually, it's a triangle, that is why you have to use the triangle formula, that is half into 90 into 3 into 1.5 divided by 3I actually. So from there we are getting 2MA plus MB equals to minus 135. So span AB and BC, so MA into 3 by I plus 2MB into 3 by I plus 3 by I plus MC into 3 by I equals to minus 6 into 1 by 2 into 90 into 3 into 1.5 divided by 3I minus 3 into 2 by 3rd into 45 into 3 into 1.5 divided by 3A. MA plus 3MB equals to minus 225. So MA equals to minus 45 kilonewton meter and MB equals to 45 kilonewton meter. The shear force and bend moment diagrams are like this. And analyze the continuous beam by the three moment equation. Draw the shear force and bend moment diagram. The simply supported movement diagram on AB, BC and CD are shown in figure. Since the support A is simply supported, MA equals 0, the moment at D is applied like this. So that's all. I am stopping here and I am going to continue in the next session.